I'm using UV light to excite molecular motions, and then I use strong infrared laser pulses to blow the molecules up.
I work with the far infrared, the near infrared, and also the extreme ultraviolet radiation for applications, for example, DNA.
I use high-intensity, long-wavelength optical excitation to study ultrafast dynamics.
I'm using visible, near, and mid-infrareds to investigate the phenomena of high-order harmonic generation.
I use mid-infrared laser pulses in order to study exotic solid material properties.
With the coherent rainbow of light we have available at ALLS, we can literally shed light on all kinds of chemical reactions or physical transformation.
The intense beam lines of ALLS, combined with the unique expertise of our users, allows us to push the frontiers of ultrafast laser science.
ALLS really helps to combine exciting science, highly skilled personnel in an international context, which makes it very unique.
The Advanced Laser Light Source, shortly called ALLS, is based in Varennes, near the city of Montreal. ALLS was funded in 2002 under the leadership of Professor Jean-Claude Kieffer. About 5 years ago, we have received a major investment to upgrade the laser to 750 terawatt of peak power, the most powerful laser in Canada. And now, thanks to the Quebec and the Canadian government, we are upgrading the facility with high average power lasers.
ALLS enables the coherent femtosecond rainbow by first starting off with intense titanium sapphire lasers at 800 nanometer wavelengths, which is the near infrared. Now, the unique point about ALLS is that it uses nonlinear optical interactions, intense laser matter interactions, in order to generate what we call secondary sources at different wavelengths, from the X-rays, the extreme ultraviolet, the mid-infrared, and even what we call the far infrared, or the terrace regime.
ALLS is a user facility open to researchers from academia, government, and industry interested in the development and the application of novel ultra-short light sources and particles.
ALLS brings people together from all over the world. For example, we had a beautiful international collaboration just recently filming a chemical reaction, and the camera we are using for this is based on Coulomb explosion imaging. So we are blowing up the molecule, we are collecting the fragments at different times. To understand the motion, we had a really huge collaboration with people from Canada, but also from the US and from Japan.
The ultrafast technologies that are developed here are transferred to Canadian companies, including a spin-off of ALLS, FuSycle, for their commercialization.
ALLS has a long tradition to support academia industry collaborations by providing a state-of-the-art platform to test new ideas and prototypes. Compressed ultrafast photography, short for CUP, is the world's fastest receive-only camera. At ALLS, we have established the CUP end station. This unique image modality attracts Access Photonique, leading manufacturers of straight cameras.
We do high-quality research and we keep the infrastructure state-of-the-art, and by doing this, we are able to attract top talents from the world.
My research mission is to build a next-generation time and angle resolve photoemission system, and I truly believe that ALLS is one of a few places around the world where I can achieve this goal and explore ultrafast dynamics in quantum materials like never before. The system will be ready by the end of 2021, and it will pave the way towards exciting and unexplored investigation in ultrafast science.
ALLS plays a major role in the training of students and postdocs by providing state-of-the-art equipment and the support of an exceptional technical team.
I have entered the 5th and the final year of my doctoral degree.
I'm in my 3rd year of PhD.
I am postdoc at INRS. I joined ALLS because of its unique infrastructure, home of the most powerful laser in Canada, and because of the cutting-edge research that's being done in the facility.
By working in ALLS, I have gained an invaluable experience of working with highly intense and ultra-fast laser sources.
I learned a lot here. I learned all my experimental skills in optics and also a lot of theoretical knowledge on solid-state physics.
I developed new radiation detectors to measure our particle beams, and on the other side, I developed simulations on the largest computer clusters in the country.
So all staff helped me a lot in my training as they taught me most of my experimental skills. They also helped a lot with quick creative problem solving in the lab.
The setup of my experimental workstation was only made possible with the help of technical personnel to implement practical solutions.
INRS is a university highly oriented on research. This makes the institution the best location to host a major infrastructure like ALLS.
INRS is the Institut National de la Recherche Scientifique, and it's dedicated exclusively to graduate level research and training. It has built its success on interdisciplinarity, innovation, and research excellence. ALLS is a very important facility for INRS. It's a unique infrastructure that allows our researchers and our students to conduct important research that will advance science. I invite you to come visit us if you're in Quebec City or in Montreal. Our doors are always open.